difficult than others because of the 1/3 there. There's a couple of ways to do it. So one way is to literally use a calculator, which I don't know if you're allowed to use, but that's, obviously the most direct way.
Yeah,
Second,
I can use Desmos actually.
okay, and the other is to use properties of logarithms. Okay, which is your test going to be show work, or is it just final answers? What do you expect?
It's just final answers because it's all on a computer.
Okay, so in that case, I mean, you can just directly enter this into a calculator and get the right answer. There is one formula that might be useful. Log base b of a is equal to the log of a over the log of b. So in this problem, it would be the log of 243 over the log of 1/3. Okay. But again, like if you have a calculator, you can directly do this. But the next property here is to basically rewrite. It's not even a property. 243 is 3 to the power of 5. And then 1/3, this one's a little bit more unusual, but it's 3 to the power of -1. Let me know if that's unclear, because this is an exponent rule here. So we're just manipulating these two lines here. Is that okay? Is that clear?
Yeah.
All right, great. So now the next property is that the log base b of x to the n equals n log base b of x. And essentially all we're doing is moving that exponent out in front. So the exponent was up here, now it's out in front as a coefficient. We can use that in this line by bringing both of these out in front. So it's 5 log 3 over -1 log 3. And you see how the logs cancel here? Because they're the same. So this becomes -5. And that's what you already selected. So your answer obviously is correct. Would you like one like this to try on your own? However you want to do it, either with a calculator or...
I mean, if I just put it into Desmos, would it give me the -5, or do I have to like write it out as all?
Let me make sure I know which one you're using. You're using the scientific.
Yeah, the graphing calculator.
Yeah, so I've got that up on another screen here. Let me just take a look here. Function. So it does not have the base. Let me share my screen on this other window, and let's just take a look at it together. That way we can both know the answer to this. So I'm going to new share this other window. And when I'm looking at this window, I see, okay, there's log. And I don't know if you can do an underscore. Yeah, you can. So you can do an underscore there. Actually, didn't like that. Let's go. Yeah, so let's try one more time here. Yes, yeah, I don't use this calculator very often, but are you able to do it where you can put in something here?
Yeah.
1/3 though. I seem to be not able to get it to work for that. Let me try one more thing here. There it is. Okay, so if I use that, and then like you said, 243. Actually doesn't like that. Maybe I got a sign error in there. Okay, let's go underscore this. So it does not look like it likes this directly. Do you see that? It doesn't seem to be giving me an answer.
Right.
So the way that you would work around this is to use that first property that I showed you, which is you would make this into the log of 243 over the log of 1/3. And do you see how that works there?
Right.
Okay, so let me go back and share my other screen, and we'll look at that maybe together one more time. So the property that we're using here is, it's called the change of base, and you don't necessarily need to know that, but you do need to be able to put it into the calculator. So let's say I ask you for log base 1/2 of 64. You would want to use this property. The log base b of a is the log of a over the log of b. So how would you rewrite this one on the left here using this property on the right?
Would it be like log 64 over log 1/2?
Perfect. And can you enter that into Desmos and tell me what you get for that, please? How are you doing on that one?
Good. I got -6.
It is -6. And you're comfortable entering that into the calculator?
Yeah.
Great. Okay, so let's move on to a new question, if that's all right with you.
Mhm.
So this one, I'm just going to go right. Well, let me first give you the property because we will use the calculator, but it's good to know why you're doing something. So the property here is that 10 to the log base 10 of x equals x. And the property is when these things match, see how it's the base and the other base, when they match, it's just the thing that's inside here. Now you might be looking at this problem saying, well, there's no 10 there, Matthew. And I'm like, you're right. When log is written by itself, this implies, and it's one of those math things you have to accept, it implies it's log base 10. Okay, so if it's not written, it's 10. Not to be confused with or exchange. If it says ln, this is not the same. ln is different. Natural log is different. So here, it is just 19. I mean, you've got the right answer here, but it's because it is log base 10. Now let's go back to that calculator and see if there's a way we can manipulate it to get that. So it's 10, and then you can use the caret log of 19. And it does look like it just gives you the correct answer here also. Okay. And you're sure you can use this on the exam? Like there's not gonna be an issue? Okay, great.
Yeah, I can use notes, I can use Desmos. My teacher's pretty cool about it.
Okay, great. All right. So let's just say I asked you for 10 log of 13. What would this equal?
13.
And how about if it's 10? Just try one more. 10 log of 10. What would this equal?
10.
Perfect. Okay. All right. So we'll move on to another problem here, and then see what else we can do here. So number 8.
And that would just be x because you're just going for like the exponent on top, right?
Yeah, it's another property here. So it's log base b of b to the x equals x, and it follows because you can actually bring this x out in front, but the kind of the sub property here is that when these two are the same, it equals 1. Are you allowed to use a reference sheet on the exam or just anything?
Yeah, I believe I can. I can use any types of notes.
Okay. I mean, it might be good to download a reference sheet or to write some of these things down in preparation for the exam. I tend to box things in that you might find useful here. That way you can get them quickly for your exam. So okay. Yeah, so the only way to kind of make this one just slightly more difficult, so let me just give you an example problem here, would be like log base 2 of I don't know, let's go 32. Because this becomes log base 2 of 2 to the 5th. 2 to the 5th is 32. So we already know that this is 5. You could obviously put this into your calculator to get the right answer there on that one, but can be done. These can all be done by hand. All right, so we're looking at question 9 is the next one to look at. This one's going to require a little more effort here. So question 9 says to find the inverse of the function. Okay, so inverses, they have a recipe. And I talk about this a lot, the steps, right? Step one is kind of already done for us. Sometimes these say f of x, it's to put a y in there. Step two is to switch x and y. So wherever you see a y, you put an x. Wherever you see an x, you put a y. And then the third and the most difficult step is to actually solve for y. Okay.
Right.
Okay, so on the left here, we have to get to y. We have to undo this log. Okay, and this, obviously this is a little more complicated, but when you have log base b of x, we looked at this earlier. If you put a b here, if somehow these are the same, then this just equals x. So on the right hand side, if we go 7 log base 7 of y plus 9, and we do the same thing on the right, 7 to the x. Okay, so on both sides here, we've used this 7 as a base. Okay, and this is the full work. You may not need to do all this when you actually solve it here. On the right, though, it simplifies just to y plus 9. The 7 log base 7, they undo each other. Okay, so now what some students do is they know this, and then they just write this next step there, and I'm okay with that. If you're showing work, you may need to show that, but you already said that's not happening. Last step here is to subtract 9 from both sides. So that's 7 to the x minus 9 equals y. So just a little rewrite, y equals 7x minus 9. Okay, so we're going to go back here. The answer that was selected here in the picture, we're going to want to change that to answer B. I don't know if you still have to submit this, but I'll snip that in. And then we'll do one like it here so you can get some practice on. We'll do another one here for this. So that obviously that's the correct answer there. Okay, so let's do an example problem. Find the inverse of y equals log base 3 of x minus 2. Okay, so the first step, sometimes this is written as f of x. The first step is to just call it y equals. That's already done for us. The second step here is to replace x and y. So wherever you see a y, put an x. Wherever you see an x, put a y. Okay, and then the step 3 is to solve for y. And this is the most important critical step here. How do we undo log base 3? And I can scroll up.
You put onto the other side.
So if we go back here to this previous step, see how we put a 7 here underneath and a log base 7 and then a 7 underneath. You want to do the same thing here. So this becomes 3 to the x, 3 is the base, 3 to the log base 3 y minus 2. Okay, and on the right hand side, these just cancel. Okay, so it leaves what we want, which is y almost by itself, y minus 2. Okay, and then so we add 2 to both sides to get y by itself. Oops, plus 2 equals y. Okay, so we got y equals 3 to the x plus 2. All right. So either take this down in your notes or take a picture real quick, because I do want you to do a problem on your own like this, just to see if you can get it all the way through, because it does look like it's something that'll be on your exam. So let me know. Either get this down.
No, all these questions on here are going to be on my exam. This is my review for chapter 6.
Okay, so let's see if you can do one on your own here. Let's go with y equals log base 4 of x plus 8. I'd like you to determine the inverse for me on this one. I'll give you 60 seconds, find out, or check back with you in 60 seconds.
Okay.
Jayla, how are you doing on this one?
I'm good.
All right. Do you have a final answer or do you need a little more time?
I need some more time.
Sure. All right. I'm going to just write write a few steps down in case you want to look at this later.
Okay.
So x equals log base 4 of y plus 8. So to undo, this is the key step here. To undo the log base 4, you're going to write 4 on both sides. So it becomes 4 to the x equals y plus 8. And then you subtract 8 from both sides. And so you have 4 to the x minus 8 equals y. How does that compare to your answer?
Yep, that's what I got.
Excellent. Okay. It's something you can do in the exam. There's no reason you can't do that, but maybe work it out one more time, one of the example problems later on before your test, or you have the notes up. I mean, I guess that would even work too. So I'm seeing question 19 is the next question to work on. Is that okay if we go there?
Yeah.
Actually, it looks like they just came in out of order.
Or yeah, they're just out of order. I have 10 next.
I'm sorry.
I said I have 10 next.
Okay,
Number
let me go look for it. Sorry for doing these out of order. I didn't. Okay, is there a multiple choice option for this, or is it just a fill in the blank?
For number 10, it's multiple choice.
Okay, the multiple choice is cut off on my side. It says write a rule for G that represents the transformation function. Okay, so here we'll talk about this. We just snip it in. All right, write a rule for G that represents the indicated transformation of the graph of F. So there's two transformations. It says first a reflection in the y-axis. Okay, so the y-axis is the vertical axis here. You know that, you've seen that for a long time now. That's number one. The second one is a translation 3 units left. Okay, so that's the second one there. The y-axis is the less common one. The x-axis is the one you see a lot more. If you were to put a negative out in front, that's the x-axis. But because it's once the y-axis, it ends up being, and this is just a known thing, like there's not a lot of explanation I can tell you, it's 3 to the minus x. So just to verify that, we're going to go back to the Desmos, and I'm going to share the graphing calculator. Are you familiar with the Desmos graphing tool? I assume you are, but you've seen this before?
Yeah.
Okay, great. So there's y equals 3 to the x, great. Y equals 3 to the minus x. Do you see that it is a mirror over the vertical axis here, the y-axis here?
Yeah.
Okay, and so you can play around with this a little bit, like if you're not sure, but if you put a negative out in front, you can see it flips over the x-axis. And so I don't really know which transformations you're going to get. It's very easy for them to switch it from x to y. So you just want to be comfortable doing both. Okay, so we know that it's a negative out in front. The next transformation, I'm still sharing the graphing window. It says 3 units left. Okay, this one I would actually argue should be written first, because you tend to reflect left or right before you do any other. I'm sorry, shifting left or right before you do any reflections. So one option here. Okay, and I like to keep the original graph. So if you hit enter and you can use copy and paste, you obviously get another graph here. So like most students say, okay, well, left means I'm going to add 3, but that didn't work there. Do you see how that moved it actually up this time rather than left or right?
Yeah.
Okay, so we actually have to apply it to the exponent here. So if you go plus 3, but notice it's inside parentheses. Okay, so we can graph a point here, 0, 1. There's a point there. And then if we go left 3, that's minus 3, 1. You can see that that is shifted there. So I'm going to go back to the other paper that we've been sharing, but you agree with this as being the final answer. Do you see that?
Yeah.
Okay, so let me snip that in, and then we're just going to give a little more context to it, because sometimes when I just show it, it doesn't mean as much as working it out here. All right, so let's go back to the other screen. Okay, so when you normally do this, you normally go left or right first when you're shifting. And I'm going to take you back. Remember y equals x squared. You either saw that earlier in the course or so to go left or right, if we go x plus 3 squared, this is 3 left. And if we go x minus 3 squared, this is 3 right. So left and right, they occur inside the parentheses. Okay. But in your parent function this time was 3 to the x. And it's like, hey, where are the parentheses? The parentheses are around the x. Okay, so let's say we want to go 2 left. It would be 3 to the x plus 2. And these are essentially inside parentheses. And then if we wanted to go 2 right, what would that look like? What would go up here in parentheses?
X minus 2.
Perfect. Okay. Now it with exponentials just a tiny bit different, right? The next one, the reflection, and this is important, if it's over the y-axis, okay, it goes from 3 to the x to 3 to the minus x. Okay, but if we go x-axis, and these are just things to write down because we don't know when they'll come into play, it's out in front. And hopefully you see the difference between those. One has the negative out in front, one has the negative up with the exponent. Okay, so let me give you an example problem to work through, or we can work through it together. Let's say you're given 2 to the x, and we want to, 1, shift right 5 units, and then 2, we want to reflect over the y-axis. Okay, and you're welcome to use Desmos. You're welcome to work this out by hand, but take a moment here and see if you can give me the new function for this. And let me know if you want me to scroll up or not.
Would it be 2 negative x minus 5?
Okay, A, B, or C here. Which one of these is correct? Or did you have another variation on this?
I'm gonna go with A.
Okay, well, we don't have to guess. We can actually go and we can just try them out here. So I'm gonna new share that Desmos window. And since yours is multiple choice, that might be a good strategy. You know, it's up to you. So there's our parent function. Are you seeing that graph, that nice graph up and to the right? Okay, so if we want to go right 5 units, okay, what do I put in the exponent? Is it x plus 5 or x minus 5?
X minus 5.
X minus 5, perfect. Okay, and I agree. Like visually, you see that that moves it to the right 5 units. Okay, but then the last piece is it has to reflect over the y-axis. Okay, so notice that negative goes out in front there, but you might say, well, hey Matthew, it doesn't look the same. So in this case, if you do it first, so if you negate it first, let's go 2 to the minus x. Okay, sorry, that let me go back to parent. If you negate it first, that's the reflection of the y-axis, and then you shift it right. Okay, we got to be careful here how we do this. So in this case, we actually want to do it opposite what you would think. Sorry, plus 5. So in summary, I guess is the order does matter. Like, did you see how all of these graphs changed where you started and stopped?
Yeah.
So in your test, you can graph all of them, but you also want to have some insight like, hey, I know that in parentheses, if the exponent is minus 5, that's right 5, or if there's a minus out in front, it flips it over the vertical axis. And since we don't know what you're going to get, you may just have to try a few of them. Do you want another example like this to try?
No, I think I'll be fine with it because I could really just use like multiple choice, or I could just like go in and like
Sure.
see,
Absolutely. Okay. So I see question 11 is next.
Yeah.
All right. Let me snip that in, and then we'll talk about how to work through it. All right, so let me share my screen and I get back to sharing that other screen. All right, so it says use log base 8 of 9 equals this, and log base 8 of 5 equals this to evaluate this expression here. So you could, and I don't know if this would actually work in Desmos, you could use that change of base formula. Log base b of a means log of a over log of b. Okay, and in this case, a is 9/5 and the b is the 8. So this would be log of 9/5 over log of 8. Okay. We can also use the numbers that they provide here. Do you have your Desmos calculator up?
Yeah.
Will you try calculating this for me and let me know what you come up with?
Yes. Let me write this down.
Sure.
I got 0.282.
Okay,
Or
let
0.2.
me. All right, let me go take a look at this because I did this the way that they want, and they did not. Let me just share screen again, that other window. I was hoping we could just directly enter this in. So let's go take a look here. So did you enter? We got to divide here. Log of 9/5 over log of 8. You did, right?
Yeah.
Okay, so this like feels like it's correct, but the problem is they don't want you to do it this way, and I don't know why. And this is one of the dangers of just like going always to the calculator and thinking, okay, I got it. So what they actually want you to do in this problem, and I'll work it out here for you. I'm gonna just go back to this other screen and we'll start on refresh here. Is they want you to use the same property that I just mentioned. They want you to use the fact that log base b of a equals I'm sorry. No. I'm sorry. This actually does work, but the the property they want you to use here is that the log base b of a over b equals the log base b of a minus the log base b of b. So they want you to rewrite this expression as log base 8 of 9 minus log base 8 of 5. Do you see how the numerator came here and the denominator came here?
Yes.
And then they want you to substitute the numbers 1.057 minus 0.774. Okay. And if you do that, you do get the 0.283. So have you seen this property before?
Yeah, I want to say I have that down in my notes somewhere, but I
Okay.
just don't understand how to really use it.
All right, so it does apply to this problem here, and but again, you could just go right to the calculator and apply the change of base formula that we worked here. So this does work. So does this. So you have options when you're taking the test here. And again, we just went right to Desmos to do that.
So I can use Desmos for these problems when like I have them written out correctly, I guess.
So sometimes on standardized tests, they don't give you the right numbers. And that's why I wanted to do it both ways to just check that this was actually, you know, they weren't trying to trick you, so to speak.
Right. Okay.
Yeah, it looks like you can just directly enter these into the calculator and they will work. But get this formula down in your notes. Again, I'm boxing in everything that you might want to include on your note sheet or have as a handy reference.
Right.
Okay, question 12 is really similar. So, except they want you to evaluate it using like this other approach. And I'm sorry to keep asking, but like you can just go to Desmos and enter this, but it's not showing your work. So I'd like you to use that change of base formula. Log base b of a is log of a over log of b. Get your answer, and then we're going to do it the other way, and we'll compare and make sure that they are the same.
Okay.
So go ahead, go to your calculator and let me know to 2 or 3 decimal places what you get here.
Okay. I got 2.453.
So we think it's probably the last answer here, right? So log base 4 of 30 can also be rewritten this way. Do you see how these numbers 6 and 5 are given? How can you use 6 and 5 to get 30?
We can multiply them.
Multiply, right? So there's this property that says if you have log base b of a times b, this is the other one to write down, it's log base b of a plus log base b of b. So notice that in the previous problem, when you are dividing, see how we're dividing here, it turns into subtraction. And when you're multiplying, it turns into addition. Okay, so that's just another formula to get out. So this is log base 4 of 6 plus log base 4 of 5. So if we go to our givens were, well, log base 4 of 6 is 1.292, log base 4 of 5 is 1.161, and do those add up to 2.453? It sure looks like they do. So in short, you could probably just go right to the calculator and enter that in, but you see it as confirmed by the expansion of the properties, logarithm properties. Okay, so let me just look here. 13 is an expansion problem. 14. Let's do 15 next because it's more like the ones we've just done, and then we'll go do 13 and 14 to review. So 15. You know, because you've been doing so well with these, you'll notice it's exactly the same. You can use the change of base formula like we've been doing. And again, that's log base b of a equals log of a over log of b. And in this case, it's log of 90 over log of 11.
And would it be 1.877?
I can double check you here, but I mean, I'm sure you've got it here. Let me just enter it into my calculator and compare. Yep, looks good to me.
Cool.
All right, so now if we go back to, what did I say here, 13. 13 and 14, we definitely have to know the expansion properties, and there's no way to do these without doing it by hand. That's just the only way. So we're starting out with log base 5 6x over y cubed, and the property we're going to use here is that the log base b of a over b equals log base b of a minus log base b of b. So again, whenever you have division, it turns into subtraction. So this line right here becomes log base 5 of 6x minus log base 5 of y cubed. The numerator came first and the denominator second, and it's subtracted.
Okay, let me write this down really quickly.
Okay, that's step 1. There's a few more steps here to get through everything.
Okay.
Okay, so the next one, do you see how this is a product here?
Yeah.
It's a product of 6 and x. So we're going to use the property log base b of a times b equals log base b of a plus log base b of b. So again, a product becomes a sum. So this becomes log base 5 of 6 plus log base 5 of x minus log base 5 of y cubed. Okay. And you may be thinking like, okay, there's a lot here. There's just one more step here. We're almost done. Because none of these answers match what you have. I mean, they kind of do, they've got the right signs, but the last property is that this exponent, the exponents always go out in front. They become coefficients. So log base b of x to the n equals n log base b of x. Basically, that number 3 is going to come out in front. So you have log base 5 of 6 plus log base 5 of x minus log 3 log base 5 of y. So it looks like the correct answer is this one here.
Yes.
Okay. So I'm going to make one here just a little bit shorter here. Let's go log base 2 x squared over y. Okay. What is the first thing that we should do here to expand this?
You should put log 2 6. Log 2 x squared.
Yep. Minus log 2 of what?
Y.
Y. So the numerator comes first, the denominator comes second. Now the next thing we can do is bring the 2 out in front. So this becomes 2 log base 2 of x minus log base 2 of y.
Okay.
All right, so since I want to make sure we get through everything, I'm going to move on to number 14, and we'll work through that. Now this one, whenever you have numbers, you can just enter this into a calculator and get an output, but we can also combine it so that we know for sure we have the right answers. So basically, we're just going to undo the previous properties, meaning we're going to do them in reverse order.
Okay.
So reverse order is we're going to do the exponents first. So this is n natural log of x becomes natural log of x to the n. You move that number out in front to the exponent, natural log of 9 plus natural log of 4 squared minus natural log of 3. Now you do actually want to evaluate it. 4 squared is 16. So we got natural log of 9 plus natural log of 16 minus natural log of 3. Okay. And then this is where it's like, well, what do I do next? Okay. Well, there's 3 terms. And if we had more time, we would do a bunch of examples, but the sum becomes a product. Okay. And here's what I mean by that. Natural log of A plus natural log of B equals the natural log of A times B. This sum right here becomes a product right here. Okay, and so in short, it becomes natural log of 9 times 16. Okay, and if you've got a calculator, you can get that number here. We're going to actually do some division, so we don't need to do it quite yet, but the next property is the natural log of A minus the natural log of B becomes the natural log of A over B. So this difference becomes a quotient. And the thing that maybe isn't said or isn't clear is that it doesn't matter whether it's ln or log, it's the same properties. Mm-hmm. Like I showed you these in the previous problem, using log instead of ln, they're exactly the same. So what this does is it becomes 9 times 16, which is 144, I believe. Is that right? Yeah, 144. Well, now we write it as 144 over 3. And natural log of 144 over 3 is natural log of 48. And you'll see that is one of the possible answers here. Now, if you were short on time on the exam, you could obviously enter each of these and then also enter the multiple choice and get the same thing. Mm-hmm. But you know, I think your mom wanted you to see the steps here, see if you could do them also. So we're gonna try that.
Okay.
All right. So what do we got left here? We got 16, 17, 18. Is that right?
Yeah. I think. Yeah. Oh, we go up to 20.
To 20. Okay.
We have like 3 more left. 17 including. So 4.
Okay. So 16. Okay to go to next.
Yeah.
Great. All right. So let me snip that in, and we'll look at it together. All right, so it says to solve the equation. One of the options here is literally to go to the Desmos graphing calculator and put this into Y1 and this into Y2 and see where they intersect, okay? That works, but I'm gonna also just work this out. Another option is to obviously just guess and check, you know, try the answers in there. Totally up to you what you do, but let me work this out. So this 1 over 100, 100 is 10 squared. And whenever you have an exponent on the bottom, you can bring it up by negating it. So this 10 to the 3x equals 10 to the minus 2 to the x plus 5. All I did is replace 1 over 100 with 10 to the minus 2. And then there's this property that if you have an exponent to an exponent, you multiply them. So this -2 is going to multiply this x plus 5. Okay, so I know, and we're going a little bit faster at the end here, but we'll get through all this. So it's 10 to the -2 times x plus 5. Since the bases are the same, base is same, you can set the exponents equal. So that's 3x equals -2 to the x plus 5. You distribute the -2, add 2x to both sides. So 5x equals -10, and then x equals -2. And of course, you could, like I said, and you know, if I were a student, I'd probably do this myself. I would just check the answers, especially if you've got plenty of time.
Yeah, that's probably what I'll do.
I understand. I want you to get a good grade on this. I'm trying to.
Oh yeah,
make sure you know that these are the options here.
Right. I'm hoping I do, because my teacher said that if I get like pretty good score, my grade will go up like a lot. So
that would be great. That'd be great.
Hopefully, okay. Right?
I think you're on the right track here. So the solve the equation here. So when they give you 4 options here, again, you could literally just check them all in there. Okay. But there is a way to solve this without that. And I'm going to show you that real quick. You would take the natural log of both sides. Okay. And then you can bring this x out in front. So it's x natural log of 3 equals natural log of 65. You divide both sides by the natural log of 3. So x equals the natural log of 65 over the natural log of 3. Now, the advantage of doing it this way is that you're going to get one of these 4 numbers. The way, if you just try it, you have to, you may have to try all 3 of them to get to the 4th. That works there. So will you go ahead and punch this into your Desmos calculator and tell me what you get for that?
Do I have to put parentheses around them?
It's a good idea, but I don't think it's necessary.
Okay.
The way Desmos should be able to handle it without them.
Right. All right. I got 3.780.
So roughly 3.8. Yeah.
Yeah, 3.8.
Good. Okay, so a couple more questions to go here. Question 18, it says to solve the equation. And again, because they give you 4 answers, like it's hard for me not to say like, hey, just try them. But let me work this out for you so you can see what the steps are. We don't have enough time to do a deep dive into this today, but
that's fine.
we can do the best.
I get most of this.
Yeah. So if you raise both sides using a base of 3 on the left, you remember this from earlier problems, those just cancel. So it becomes negative x minus 3 equals 3 to the 5th. Now, what is 3 to the 5th? You've got a calculator. It is 243. Okay. And then you can add 3 to both sides. So you get negative x equals 246. And then you negate both sides, negative 246. Yeah. All right. Let's see here. You said up to, we got 19 and 20. Perfect. Perfect here. So normally my lessons end at 50 minutes, but we're going to make sure you get through all these today. I'll do a better job of keeping track of the time. We spent a lot of time on some earlier questions. But okay, question 19, it's to solve the inequality, right? So basically this is asking, well, what number, I'm sorry, e to what number? E to what number is 25? Okay, and again, like you could literally check these here. Okay, so if you get one just like this, you can definitely do that, but let me work this out just in case you want to see the steps here later on. If you take the natural log of both sides, the x comes out in front, x natural log of e equals natural log of 25. This is a property, the natural log of e equals 1. On the left here, this is just 1. So it becomes x equals natural log of 25. And that's probably what here, maybe 1.398.
1.398, let me check.
Did that work?
It's supposed to equal 25, right?
Sorry. Yeah, it looks like it's 3.219. That was
3.2.
Okay. Yeah, there you go. Okay, last question. This one is it's a really good question actually, because it's got a kind of a little wrinkle, a little trick, if you will. It's if you get them all right, miss this one, I'm sure you'll be pretty happy on the exam. But it says to solve the inequality. Okay, and notice that all of them have numbers, but this one has 2 numbers.
Right.
Okay, and that could be like, okay, well, which one works? So it ends up that X is 10,000. Okay.
Hmm.
Now how did I find that? Let's not worry about that for the moment. We'll talk about that shortly. The graph of log X looks like this, and I don't expect you to care what the graph looks like, but I do need you to remember that the domain is X greater than 0. And that's important because you can't just ignore the fact that you can't have negative values. Now, see all of these are greater thans, greater thans, and greater thans. So these are all okay. But this one says from 0 to 10,000, meaning it's like, hey, you can only go from 0 up to 10,000, but not greater than 10,000. So we have to decide here, is it greater than 10,000, or is it between 0 and 10,000? Okay, and so again, one approach here is to actually go ahead and solve it. Log X greater than 4. What is the base here that is not written?
10.
10. So we can raise both sides using 10. And on the left, it undoes it. So it becomes X greater than 10 to the 4th. And 10 to the 4th is 10,000. So it is X greater than 10,000.
Got it. Okay.
So to summarize just for this last question, like just be careful when you see two answers that you know why you're choosing the one that is, have some reasoning behind it.
Right.
All right, well, that does take us to the end of our lesson today, Jayla. I'm going to send you the notes shortly. Best of luck on your exam. I look forward to helping you in the future, and have a great day.
Thank you. You too. I'll let you know how I do on it also.
That'd be great. I would appreciate that. Have a great night. A great day.
You
Bye now.
too.